work for Scrutinizer that I started the company for. There was so much misinformation, but this is because we are going to study the oncologist. So basically my doctorates are, I'm a medical doctor, and then I have a PhD in biochemistry, but all my research experience is in, most of it is in hematologic diseases, which means dealing with cancer and so forth. So I'm not a practicing clinician, but I'm a research scientist, which would be different than if you had come across a practicing oncologist. And so who is an oncologist? Oncologist would be a person who diagnoses and treats cancer. And there are different kinds of oncologists. There would be a surgical oncologist, for example, who removes or who performs surgery to remove the tumors. Pediatric, who will deal with the children. Then hematologist, like I said, with the bone marrow diseases like leukemia, lymphoma, and so forth. Then there is radiation oncologist who specializes in radiation treatment for the cancer patients. And there are oncologists, the most of them are who deals with the tumors. So there is a difference in the solid tumors and the hematologic tumors or, cancer. Okay, so to be a oncologist would be you do your undergrad and then MCAT, go to med school, which is 4 years. So you do a residency, but the fellowship you will specialize in as oncology. So there are all these specializations everyone can do. For an oncologist, you will do an oncology, and then you would go from there, which kind of oncologist. So there are subspecializations. Then the certifications after that, when you have a degree, then you need to take the boards wherever state you are in, then that gives you a license. And this is it, then completing the internship and residency. This leads to what the salary range, it all depends on which college you graduated from, but basically what kind of oncologist you are. So, and then experience and professional. So basically the salary range is wide at 100,000 to 400,000, but at least it's 100 starting. What's the typical working lifestyle? So it could be 10 to 12 hours. So the salary range I gave you is a practicing oncologist. That would not be me who does research. I'm a scientist. But in a scientist also, the typical work hour would be, it could be all day, a couple of days, so 10 to 12. They would be on call. And so on a typical day, a practicing clinician will see the patients. He will see the patients in the clinic. He has paperwork to do. And then there are the rounds then they perform. And then if this clinician has any surgery experience, then they would also have to perform the surgery in the same day. There would be a couple of them scheduled. So the career outlook for an oncologist, yes, it looks pretty good because the number of treated patients is going up every year. So that's why we need more and more physicians. Going from here, like I said, I'm a scientist who works on research. So sometimes in oncology, it gets very depressing when the only thing you can tell the patient is, I cannot do anything more for you. And I do not want to be that person. There are good outcomes, but I want to find cure. I do not want to sit helplessly and think I've done everything I could. No. So I want to find the cure, and that's what I've done for the past 15 years. And I have been working on gene therapy. And the way Einstein always said, and which you guys should remember, that the important thing is not to stop questioning. We need to be curious, and that leads to more discoveries. So a scientist who is not a person who will give the right answers. A good scientist is one who will ask the right questions. Okay. And like I said, being a scientist has its own, it does not give you that much money, as I said, for a practicing clinician. But for being a scientist has its own excitement because no 2 days are alike for me. And I can make medical breakthroughs, and there are opportunities to contribute to the advancement of science, care of patients, and I can teach the next generation like you guys. And a typical day in my life is, first I get hounded by my mice, but meaning they are my little patients and I have to go check on them. And the gene therapy, like I said, I've been doing gene therapy for cancer. It means that it hasn't been much successful in humans, but in the mouse, you can take the defective gene out of the person and you can replace it with a normal gene. So that is the basics of a gene therapy. And the principle seems very easy. Like I said, take the bad gene out, put the good gene in, and the person is cured. But it has been really, really difficult to deliver the healthy gene and for it to stay in there. Okay, and the main difficulty in this case has been that you have to control the gene so that the protein is produced only when it's needed and where it's needed. Because being and doing research on oncology, this would be like a cliche, because sometimes if you do gene therapy, you can wake up the oncogenes if we cannot control where we are putting the gene in. So that would be giving the patient cancer. I mean, you can treat something else, but you could give them more cancer. So that is one of the other reasons we need to control where we place the gene. Okay, so for the study, like I said, because being a scientist, we cannot just go do an experiment on the humans. So these are the mice that I made, which are the knockout mice, where I took the functional gene out, so now they have a disease. And this is the red sequence I was showing, where this is the human cDNA, where with the enzymes I can cut the corners and take this chunk out. And here I was trying to say the viral vectors, meaning that I have taken the disease-causing portions out of the vector, and I can, so we can put any of the DNA that we want in these vectors, like the cargo trucks, so that they can produce the gene we want. This is the mechanism that, so for example, here the green gene is a normal gene, and I would like to place it in the diseased animal. Okay, so I took the normal gene, the enzyme, and placed it in made a new DNA where this is going to integrate. So you see this, there is the normal DNA outside the animal's DNA, but this is a gene it was lacking or it was not functioning. So I replaced the non-functioning with the functioning gene. And now I have a full construct that if I place it in the animal, this should start making the protein that was lacking. So that is called gene therapy. So what I would do is I'll take the mice that have the disease, the cancer or FA, I take their bone marrow out. And this is cultured, for example, in a Petri plate. And then they are mixed with the construct we made, okay, with the healthy gene. So this grows, produces protein, and then I transplant this back into, these are called the corrected cells, into the mouse. So we can just give him an injection like the human patients and treat. And then from there, it depends on the kind of treatment they're getting. But otherwise, they should start making the corrected protein. And after 1 month, we just follow with the blood draw and see if the normal protein is being made. And how do we go into looking at it is, so this is called, we can do a PCR, which is the polychromatic chain reaction, because in that I just need some nanograms of DNA and I amplify it and I see whether my gene is being made. So here, if my gene had not integrated the good gene, then I would only see, like in the first, where there is no integrated gene, there I only see this top band. However, as the days pass by or the number of copies increase, so I start seeing the second band, meaning that my gene was successfully integrated, it was successfully corrected, and the animals are producing the protein I wanted them to. This is what I wanted to show, but because I also said that I'm a geneticist, and so I did want to understand and do research, but my main aim was to create the Pokemons. And but you will go in science to do the science stuff, I'm assuming. Okay, so shall I go back in anything if you guys have time, or you can ask me questions?
Where did you go to school?
Where did I go to school? I'm from Germany, and I did a doctorate in Germany, and I went back to do a PhD in biochemistry in India. And in US, I've been working at Oregon Health and Sciences University for 15 years. I did a postdoctoral fellowship here.
How long are your days of being an oncologist?
Yes, as a research scientist, there is no schedule, because I mean, in a way, I can make the schedule, but if the experiment is running, I may not go home for days, because then I have to be there. But usually 10 to 12 hours is a minimum, because it's not only doing an experiment, it's reading the journals and participating in, every day we would have a seminar, a journal club. So all those things need participation as well.
Have you ever had a breakthrough?
I had a breakthrough, actually. Like all the breakthroughs are accidental, and I was sequencing a DNA when I worked on Wilson's and Menkes disease. These are copper metabolism diseases of the liver. Then by mistake, when I looked at the sequence when the lab sent me, this means I had discovered a transcription factor, which is involved in the copper metabolism. So I got to name the transcription factor. I did not want to name it after me, but I named it a ZRAP because it was a zinc resistance associated protein. So it goes in the database as that I discovered it, and I get to name it. And the other thing with gene therapy, like I said, in the mice, it worked really well. And if somebody goes on clinical trial, then there might be a cure for Fanconi anemia or maybe leukemia and so forth.
Laura Belray, thank you so much.
Okay, thank you.